Hi, this is Blake Smith from section MO4. For this lab, I shot a free throw and modeled the motion of the basketball with VPython. To model a motion, I used the momentum principle and the energy principle. The momentum principle is defined as the change in velocity is equal to the net force divided by the mass times the change in time. The energy principle in this case is defined as the change in energy is equal to the change in potential gravitational energy plus the change in kinetic energy. I use the momentum principle in my code to update the position of the ball. I use the energy principle to determine the vertical component of the initial velocity. Using the program called Tracker, I track the motion of the ball. I use the position data from Tracker to determine the horizontal component of the initial velocity. Then, using the initial position, the total time, and the initial velocity, I found the model of motion in VPython. So, mass, initial position, initial velocity, and the total time down here. Once I had all the initial conditions in place, I used the momentum principle, as seen here, to determine to model the motion. Right in here. The fnet, ball.vel, and ball.pos. However, the model of the ball's motion did not match the actual motion of the ball, as the ball goes down much further than the actual motion. Therefore, there must be another force acting on the ball, such that the ball will fit the actual motion of the ball. To account for this, I included the force of drag. Because the force of drag is not the same in all cases, I found a constant b, such that the model and the actual motion are the same. B are defined right here. Once I had the constant b, I added the drag force to the net force equation. The motion of the model and the actual motion matched. The room for error in this experiment comes from human error using Tracker and the positioning of the camera when I took the initial video.